Hello, pre-algebra students. Mr. Lawrence here, and I put together this video because I heard a rumor that you guys are going to be having a quiz on Wednesday, and I thought I'd like to help you get ready for it. Now, after this video, it's all review. We're going to be saying I can calculate the volume of cubes, rectangular prisms, triangular prisms, cylinders, pyramids, and cones. Now, remember to do this, we use two basic formulas, V equals capital BH, or V equals capital BH divided by 3. Remember, this one is for cones and cylinders. Oh, no. Cones and pyramids, excuse me. What I was thinking in my head is that a cone or a pyramid is a third of either a cylinder or a cube. All right. And then the capital B is the area of the base. So this is going to be a little bit longer video, so I don't want to take too much time. So let's get right down to it. First of all, we're going to find the volume of this cube. And remember, I'm going to find the area of the base. And remember, my friend Chris was highlighting his bases the one day. Thought it was a great idea. Okay. Highlight his base. Going to find the area of that, which should be pretty simple because he's going to go 6 times 6 to get 36 centimeters squared. That's the area. So capital B is 36 centimeters squared. Now all he needs to know is how tall the cube is, which in this case it's 6 centimeters. And then he can just multiply them, which I believe is going to come out to be 216. But let me just verify that. 6 to the third power, yeah. So it'll be 216 centimeters cubed, okay? Now, knowing Miss Eubank, she likes to push you guys just like I like to. She's going to ask you something like, what would happen to the volume of the cube if I doubled the length, width, and height? Well, you could do two ways. You could go 6 times 6 times 6, and you get 216 centimeters cubed. And then you could double it, 12 times 12 times 12, which off the top of my head I don't know. Looks like that's 1,728 centimeters cubed. And then you could take the 1,728 and divide it by 216. And that, I know what it's going to get me. That's going to get me 8. That means the volume increased 8 times. Did you hear that? The volume increased 8 times. It's 8 times greater. Now there's an easier way to do it. You could have said, well, let's see, I'm doubling the length. That means times 2. I'm doubling the width. That's times 2. And I double the height. That's times 2. And 2 times 2 times 2 equals 8. I like this way better because it's 8 times larger. It's a little bit less work. And it shows I understand it. But either way is acceptable. If you have another way that's acceptable, that's fine. But you got to make sure you can't be stubborn and say, well, I like my way better if your way doesn't produce the right answer. Okay, so let's get on to this rectangular prism. Again, I'm going to highlight my base. Where did my pen go? There it is. I'm going to highlight my base. Okay, so to figure out the volume, first I'm going to figure out the area of that highlighted piece. And that's going to be what? 15 times 5, which I believe is 75 inches squared. So now to do volume, we're going to substitute 75 inches squared in for capital B. And we're going to multiply by 10 inches, because that's how tall the prism is. And we're going to get 750 inches cubed. And there you go. Now, what would happen to the volume if we doubled the length, tripled the width, and quadrupled the height? Well, again, I can do two approaches to this. I can go 15 times 5 times 10 and say that equals 750. And now let me see, I have to double the length, 30, triple the width, 15, and quadruple the height, which would be 40. And multiply all those together. So 30 times 15 times 40. And I'm going to get 18,000. Put my comma in the wrong spot there. Sorry about that. All right, hold on. Let me rewrite that. There we go. 18,000 cubic inches. Now I could take that 18,000 and divide by the 750. This will tell me how many times greater my new volume is. So I divide by 750 and I get 24 times greater. Okay, now again, there's an easier way to do it. What would happen to the volume if we doubled the length? That's times 2. Tripled the width, that's times 3. And quadruple the height, that's times 4. And 2 times 3 is 6, and 6 times 4 is 24 times greater. It increases by a product of 20, or by a factor of 24. 25 times greater. So notice we get to 24 this way or we get to 24 that way. I personally think the blue way is simpler, but you do it the way you understand it best. Okay, let's move on to a triangular prism. And I'm going really quick here. You can always pause the video. Okay, I need my base. Well, remember, my base is going to be the triangle. So I'm going to highlight that triangle. And to find the volume, I'm going to use the same basic formula. Volume equals capital BH, only capital B in this time is going to be little b, little h divided by 2. And then we're going to multiply by this h. Now some of you are going to get confused. This h here is the height of the triangle. This h here is the height of the prism. Okay, in other words, how long the prism is in this case. So I'm going to do area at the base, which is 20 times 15. Divide that by 2, and then I'm going to multiply by 30. And I can do it this way, turn that into 10, and I'm going to get 150 times 30, and 3 times 15 is 45, and then times 100 is like that. And we are in millimeters cubed. What did I do? I did the area of this yellow part, 20 times 15, divide by 2. And then I multiplied by how tall it was. Remember, you can think of a prism as a whole bunch of bases stacked on top of each other. This triangular prism is like a whole bunch of triangles. If you know the area of one of them, you could figure out the whole volume if you just multiplied by how many triangles there are. What tells you how many triangles there will be? The 30. All right, so there's a triangular prism. Let's do a cylinder. Again, we're still going to use V equals capital BH, only this time capital B will be found by doing pi r squared. Okay, and then we're going to multiply by the height. So pi is approximately 3.14. R is 5 squared. And then we've got to multiply by 15. And that will get us our answer. So 3.14 times 25 times 15. We're wondering where 25 is coming from. It's the 5 squared. So I've got 1,275 centimeters cubed because we're doing volume. Centimeters was here. We had 5 centimeters squared, which is 25 centimeters times centimeters squared. And then this 15 is also 15 centimeters. So there's where the cube comes from. We got centimeters squared times plain old centimeters. All right, moving right along. Again, if I'm going too fast, slow it down, back it up. All right, now, knowing Miss Eubank, there's probably going to be a problem where you have to use the Pythagorean theorem. At least one. Okay. Well, to do the volume of the cone we have here, of course, we're going to do V equals capital BH, and then we're going to divide by 3. But we don't know the height of the cone. We know this L thing, which is slant height, right? That's the slant height of the pyramid, but that's, or the cone, but that's not how tall it is. So we're going to set up the Pythagorean theorem to find h. And so I'm going to go h squared plus 6 squared equals 10 squared. H squared plus 36 will equal 100. Subtracting 36 from each side, I'll get h squared equals 64. Take the square root of each side and I'll get 8 So h is 8. So now I'm going to do pi r squared times h, and then I'm going to divide that answer by 3. All right, so pi is approximately 3.14. The radius is 6 squared. H is 8. We found it from the Pythagorean theorem, and then we're going to divide by 3. Okay, and I'm going to try to make my math a little bit simpler. Squaring, following the order of operations, and now multiplication and division have equal importance, so I'm going to divide and turn that into a 12. And so I'm going to do 3.14 times 96, and I'll go to my calculator for that. 3.14 times 96, and I'm going to get this answer of 301.44 hundredths inches cubed. All right, there is the volume. Okay, I did it slightly out of order. If you want to do it from here and do it in a different order, that's perfectly fine. Okay, finally, we have the volume of a pyramid. And again, it's V equals capital BH divided by 3. I need to find the area of my base in a pyramid. That's easier, especially when it's a square pyramid. Okay, so the area of that base is going to be found by doing 8 times 8, or 64 inches squared, right? So that's 64. Going to multiply by how tall the shape is, which is 12 inches. Should be inches squared, sorry. And then we're going to divide by 3. Now, again, I can divide first if I want to here. I'll go 3 goes into 12 4 times. I know my answer is going to be in inches cubed. I think that's going to be 256 inches cubed. Warning how I did that so fast. I doubled 64 to get 128, and I doubled 128 to get 256. Doubling a number and then doubling that answer is the same as multiplying the original number by 4. All right, so remember, in all these videos, we found the area of the base, and then we multiplied it by the height of the 3D shape, right? Okay, now with the cone and the cylinder, I keep doing that, pyramid, it's the same formula, except we have to remember to divide by 3. Okay, because remember, 3 cones make a pyramid. 3 cones make a pyramid. 3 cones make a cylinder. Remember, Miss Eubank demonstrated that by pouring the blue water. And then 3 pyramids make a cube, and that's what you did when you worked in groups, and we did a third of a cube exercise. Okay, that's it for today. Mr. Lawrence signing off. Good night, everybody.